Hi guys. Before others join, I was just curious, do do we keep an agenda for this meeting somewhere? Um, Maybe that's in the wiki page from OSF. Does anyone know?
Good morning, Kim.
Today the agenda was in the email, but yeah, I don't think we have a like place on the web where we archive prior agendas.
Yeah, I think there was nothing mail. Probably, I think we can just go to the any opens and work stream updates. I don't see Raj or John Marie. Let's give one more minute, maybe. Probably let's get started. I don't know whether Raj able to join. Do we have any opens? If not, I hope all of you submitted the Global Summit abstract on Monday, by Monday. I think there's a review is getting started. I think once we have the review done, you will get an update if you submitted any abstracts. I believe it's probably a week or two. I have not looked at the timeline on it, but it's posted there. Any questions or comments? Yeah, I'm just looking at the July 14th is submit is getting notified. So it's probably 3-4 weeks to close on that, I believe. And Raj just sent a note saying that he's not able to join. He has conflict. Maybe let's just go through any work stream updates we have, and we can probably close early today. Felix, you want to give an update on your work stream?
Yeah, so yes, I submitted the presentation proposal, and in general, I kind of don't have a lot of people today. So we had the discussion as far as which binary format we need to pick, and then the Raj came up with kind of the first proposal where he's comparing different format and arguing for usage of the CBOR format. So I think he's doing fairly good job as far as comparing different serialization format, and then CBOR definitely has some advantages for us for the firmware case. It's just the key question whether we uh, really need like some kind of serialization format or streaming format, or we are good to go with like raw binary buffers. So that's I mean, and of course the answer depends on the use cases. So I kind of started preparing that like pros and cons table. So maybe next time we can have that discussion to kind of finalize the choice.
Okay, so you're going to prepare the pros and cons list, Felix.
Yes.
Okay. And who is there any specific input you're looking for people to start?
So
preparing
maybe
something?
that document is out there in the UPC folder. So I would encourage. Actually, there are two documents, but they kind of similar. It's almost like two different editions of the same document, so people can read like either one and to form the opinion whether they believe something like CBOR is beneficial or that's a necessary overhead, like compared to a raw binary buffers that we've been dealing with up until now.
Guys, these documents, can either of you share the link to the repository where
Yeah,
these
so
things are?
the best option, we created a folder where we keep all our documents. So the easiest if you get access to the entire folder. I can, yeah, I'll share the link, but then you'll need to probably request the access.
Yeah, that's fine. Thank you, Felix.
Yeah, if you can send out to the whole group, the people who have not joined also, they could have access to that link.
Yes.
Any other update, Felix?
No, that's probably the update. Yeah, so I just posted link to the folder to the chat.
This is a common folder for both the work streams, right?
Yes. Yeah, and then there is a UPCI folder and then specification subfolder. That's it has the documents I was just talking about.
Any questions? Any other questions or comments?
I do have an overarching question, although I'm not so sure whether we want to have this discussion today. But on this UPC proposal of going with CBOR, I was wondering whether we really need to nail down or specify a particular binary type or the way we serialize the information, or whether we should just describe the information that would need to be passed.
Yeah. So what I was thinking, so sooner or later we'll have to start defining specific data formats for particular use cases, right? Like, I don't know, CPU information, memory information, things like this. I don't know, I2C configuration. So, and then if we are defining the data structure, then I guess we need to define the binary representation of those data structures. But I guess you didn't say it, but I hearing some doubt. I also share the doubt. I'm not sure we need something as as advanced as CBOR, but that's what I'm saying. We need to have that discussion. We need to prepare pros and cons. Like, yeah, another alternative is something very simple, like even that ARM firmware handle spec, just a basic sequence of tables with a clear tagging. So what are we missing, or what cannot be done with and of course by default simplicity kind of should prevail. So we need specific argumentation why we want to go to the next step. And I was trying to do this analysis. I think I came up with a few points that we can consider. But again, maybe if we have time left, once we're done with the agenda, we can have this discussion right now, or otherwise, let's schedule specific date to have this discussion.
Do we want to have the discussion today, or we want to have it another time?
Like that email that Raj said, I think it had a lot of items. So Sam, if you want to go through all of them so that at least we can have some discussion on each item, then if you have time left, we can get back to this.
Yeah, I'm fine going over this OpenSFI draft. There's just not very many people here. I don't know if it's going to give us much benefit to go over it today. We may have to set up a separate call to start looking over this. That would be my suggestion, just because the crowd here is pretty light today.
Yeah, I agree. I think it'd
Yeah.
be good to have a full crowd, so you don't need to repeat it
Yeah.
again. And
Yeah,
also, it'd be good to have a good discussion. So when we
As another quick topic, item 5 on that list that Raj sent, the OpenSIL specification that we submitted to OCP, that process is underway. It's all been submitted. Presentation has been submitted. We're just waiting on next steps to present and then move forward.
So, but I have a quick feedback for that OpenSIL specification. So number one, probably we should explicitly define the ABIs, right? When we are calling for these functions, what are the calling conventions that we use, right? Something like similar to that chapter 2 in the UEFI spec, or maybe we can refer to the existing document.
Yeah, that's true. We hadn't really mentioned the ABI in there. I think it was meant to be OpenSIL was independent. Well, we support the two main calling conventions, right? The MSVC calling convention, and then the what's the other one? I forgot the name. The GCC.
Yes, it's System 5 or
System
something
5,
like that, yeah.
right? Those two. We could definitely spell those out though.
And then another, like just a suggestion for the initialize silicon. One of the parameters is a stage, and I assume probably not all the stages will apply to all these types of silicon.
Yeah,
So
that's
maybe
and you're referring to the OpenSFI, right? The
yeah, OpenSFI,
OpenSMI,
yes.
right, mentions a stage. I had brought that up actually, because these stages essentially are an enum, an enumeration, right? That means not all stages will be relevant for all silicon, right? And to me, that I had one suggestion to maybe move away from very discrete specific names for these stages and make them more general, where you could handle, for example, pre-memory stage, where you could handle anything related to memory, or things of that nature, rather than specific feature initializations. Memory initialization, right? That for Intel and AMD, that means two different things.
Yeah.
Right.
Yes, so that's one approach. And then what I was thinking, maybe we can also add an API that returns stages supported by the silicon.
Oh, that's a good idea. And
then maybe we can specify that unless otherwise specified, the API should be called in increasing numbers. Like if you can't call stage 5 before you call stage 3, for example.
Right. Okay. Yeah, that was one thing, the stage names that we faced with. I think we talked about it during the face-to-face. The stage names applying numbers to them made it difficult to extend, right? If you have a stage 1 and then you find a stage prior to that we wanted to execute, then you'd have to start going into the negatives, stage 0, stage -1, and things of that nature. So, but for sure, having an order, right, a defined order, I guess that would be determined by the sock itself, or the silicon itself, right? The order of the stages. Let's see.
Yeah, maybe one thing we can do if we define them if as ranges, for example, pre-mem, instead of being 0, let's make it 100 or something. That way,
Right.
if we need to add something, we don't have to go negative.
Right, that's true. Okay,
Is there any
let me look at
other
that.
things that we want to discuss today?
So I do have a basic question about the model for OpenSIL. I see that the interface definition has two functions today. That's the initialize silicon and execute silicon runtime op. And I appreciate the flexibility that it has, that these functions take a parameter to where the caller provides more intent on what it's exactly trying to achieve. But I was wondering, so these are C function calls, or they're defined as C function calls. Is there a built-in assumption that the caller is linked with a library that implements the logic of these functions, which may rely on communication with some microcontroller or some other processor?
So the OpenSFI will define an interface, right? So it will provide an API to start the silicon initialization, right? That is the layer between the firmware and the silicon. So once we get into that shim layer and we start initializing the silicon, then vendors or customers are it's up to them how, what happens in the background, right?
Yeah.
What happens behind the scenes is we're not trying to control in the spec. We just want to make sure that there's a common interface to that to get to that silicon initialization, right? So
Yeah,
whether
so I do understand the benefit of having this abstract interface. It's abstracting the functions for the firmware to request some silicon behaviors. But I was trying to see how this is realized in practice. So is it that the silicon vendor is going to produce a library that, say, an eventual OEM is going to link against?
It could be a library. I think that's one thing right now we've really been focused on UEFI, for example, right? So UEFI has an option, and of course that has to be extended. The phase 1 is to align Intel and AMD, right? Once we have alignment there, then we can moving things to other firmwares, right? We can't take UEFI drivers and put them into a core boot environment, and that's how OpenSIL was developed. It's a set of libraries, right? Then the libraries are linked against an interface driver for a specific host firmware. I would imagine for OpenSFI we would want a similar something similar, right? We would provide libraries that have the interfaces for OpenSFI, and it would require an interface driver. Or I mean, you could also natively interact with the libraries, but there are complications when you try to implement it in that fashion, right? I mean, libraries they don't share memory space, right, in different instances. So, and that is a complication in OpenSIL as well. So, that's something I think we can still explore and discuss the best way to do it. But certainly, I think if you want to make it scalable to other firmwares, we will have to rely on a library model.
Yeah. Thanks, Albert.
Any other discussions we want to have today? So if not, so Felix, do you want to send any instructions before the next meeting to others to review or anything?
So yes, yeah, I'll try to send something out before the next meeting.
Yeah, that way at least the people who have not joined at least have the context what we want to review there. Any other opens before we close then?
Like
If not, yeah.
maybe yeah, if there are no opens, I would like to maybe still just a little bit go back to that topic. So like as I said, as far as the binary format for the platform configuration, kind of by default, like the binary buffer is kind of the prepared option. So I was thinking what could be the advantages of something more complicated, specifically, for example, CBOR. So one potential reason, like it maps almost one-to-one to JSON. So conversion from JSON to CBOR and back is very straightforward. Now, why we might need that? For example, the MHS plug and play workstream, they define their configuration in terms of JSON. So as I understand, the idea is that that's their final formats. That's what they operate with. So for example, if you want to align to them, of course, for the firmware, JSON is not the most convenient format. So one option we can have, if we have our like board topology or board configuration described in the format of CBOR, it's very easy for us to, for example, export it to JSON to be used, for example, by OpenBMC, something like that. Then another potential reason, kind of related. So JSON, CBOR are good at describing structured data. So as far as like vanilla configuration, here is the device, here is a bunch of parameters for the device. Probably CBOR may seem like an overkill, but if you're talking about maybe PCI configuration where you have to describe the hierarchy of devices or even like different buses, then something that kind of format that natively support structured descriptions are beneficial. But then again, if we are sticking with something that natively supports structured definitions, then things like device tree or even AML come into the picture, and we have to again answer the question: why are we picking like CBOR, which is not a new format, but is not used for these kind of things. But I'm saying if we stick with the binary buffer, then we will need to essentially define our own way of describing those nested data structures. Another advantage of CBOR is CPU architecture. Like it's actually a big engine format, so we don't have to like little engine, big engine. It is standardized. Now, if we are talking about strictly about host CPU firmware, I'm not sure if that's a big advantage because of as far as I'm aware, like ARM supports both engines, but in practice, people mostly use a little engine. But if we become successful and that format is used by multiple platform firmwares, then this may come as also as an advantage, as a benefit. And yeah, another advantage, like essentially when we are dealing with a raw buffer, it's a black box. So we have a pointer, maybe we have a size, but beyond that, it's a black box. The CBOR allows us to decomposition that raw buffer into primitive types, like and not the standard types. I have to say, like integer, boolean, array, mapping, strings. These are the types supported of by CBOR. So essentially, that one black box becomes a drawer full of black boxes. So and does it gives us anything, any value? That's something to think about. It may bring additional value if we are talking about some automatic export, for example, if we need to convert platform configuration into the Redfish attribute registry, that may be a benefit. And then finally, yes. If we discussed one of the goals we want to achieve is to ability to maybe override the data. For example, you have default configuration and then your active configuration that has been provisioned by BMC or even by setup application. So in case of binary buffer, we can do like in-place patching, something like that. In case of when configuration is structured as a name value pairs as a mapping, it kind of natively supports data packages which supports partial information. For example, I don't have to duplicate entire data structure. I can just say, okay, a base address equal whatever 27. The rest can be extracted from the default configuration. So it's a kind of a preview. So I wanted for people who are here to give you additional kind of food for your thoughts. So these are, and then again, I'm giving you advantages of CBOR. It doesn't mean I'm advocating for CBOR. To me, you don't need any arguments to stick with your raw buffer. That's kind of the default option. That's why I'm trying to present you the other side. What are the reasons where you might consider going like with that added complexity and additional data footprint overhead?
So if I were to add some arguments, not necessarily against CBOR, but an alternate view there, and also focusing a bit on the raw buffer. If NDNS is an issue, we can set constraints on the raw buffer, saying that it's either just little endian or big endian, right? So we do have that flexibility as well.
Yes.
So I'd claim that the NDNS is it's not an issue, right?
I agree. Even if it's an issue, it's not. It's a low priority. I just kind of include it for the sake of completeness,
Yes.
more than anything else.
And in terms of the flexibility that CBOR or any self-describing blob gives us, I mean, it's evident. It's human readable. There's tooling to go and manipulate this, but there's also the downside there that we require an interpreter.
Yes.
And interpreters are fine, but like for some firmware environments where you might have constrained resources, those are a big tax to pay to having to cram there the interpreter to be able to access and manipulate these data blobs. So that's something that I think we should be wary of. And then I'd also add that these advanced self-describing data blobs, they're very useful for advanced software and firmware, which I assume generally is going to execute very late in the platform boot. And I'd claim that the raw buffer can encapsulate or can contain such CBOR or device trees within it to cater for these use cases where I think you've mentioned the MHS plug and play and some other firmware or software components where they either use JSON or CBOR. The raw buffer could still pass those along for these advanced firmware components. So sticking with a raw buffer doesn't prevent this, doesn't make all the flexibility go away. We can still support it where relevant. Right?
Yeah, I actually agree with many of these arguments. So maybe like your original remark that you said that maybe we don't have to define the format. I think we do have to define the binary representation, but maybe we don't have to start with that. So maybe one way to go forward is to, as we were planning, to look at specific use cases, come up with the specific formats for those, and then based on those, we can maybe they will help us to answer the question: does it work better as a raw buffer, or it does not, and we have to, do something else. So maybe that's another approach. Yes, we can, as we plan, pick specific pieces of board configuration, come up with the human readable format descriptions, and then they will help us to see what's the best binary representation.
Yeah, that makes sense. Thanks, Felix.
Any other discussions you want to have? Okay, if not, let's close early today and see you guys week after next. Thank you.
Thanks.
Thanks.